Hey, math students. GED student Shelby had a question about least common multiples and least common denominators. So I did the least common multiple video already. Wanted to show that to you guys first. So if you haven't seen that one, I suggest you go back and take a look at that video because you need that skill in order to understand this video. And also another prerequisite skill that you need, which probably actually should come before LCM, is prime factorization. That will come up in this video as well. So if those are two skills you do not have, those are both two types of divisibility skills. Divisibility skills really build on each other. So I suggest you check those two things out before viewing this video. But if you know about prime factorization and you know about LCM, you should follow along just fine. Okay, so let's take a look at this. We're talking least common denominator, often abbreviated in math as LCD because, as you know, mathematicians are too lazy to spell. So we'll often call this the LCD, the least common denominator. So what is it? The definition of a least common denominator is it's quite literally the LCM of the denominators. Now, that's why I said you better know what an LCM, a least common multiple, is before you start this video. And then you should also know what a denominator is. That's the bottom of a fraction, the size of the pieces the denominator tells us. For example, on the fraction 3/4, this is the denominator. It denotes the size of my pieces. It gives name to the size of the pieces, okay? So I have 3/4, okay? So if I ask you for the least common denominator, I'm asking you really, and I'm stealing this definition straight from that LCM video, it's the first time the denominators run into each other on their times tables, the first number they share on their times tables. Okay, let's get right down to business. Example 1 says, what is the least common denominator of 5/7 and 3/5? Now, I have a lot of students who don't have to do any work for this problem. The least common denominator, 35, just pops into their brain. They don't even have to think about it. For the rest of us who are not so lucky, what's happening in these students' brains? Well, what's happening, whether they realize it or not, is they're quickly running through their 5 times tables and their 7 times tables, looking for a time that 5 and 7 run into each other, share a number. And indeed, if I were to list out my 5 times tables and my 7 times tables, and again, for those of you who are not good at your times tables, I'm just counting by 7 here on my 7 times tables. So 21, 22, 23, 24, 25, 26, 27, 28. If you saw me, you would see I'm wagging my fingers like mad, counting on my fingers. So next one, I'm counting up by 7, 29, 30, 31, 32, 33, 34, 35. Okay, now I want to stop right here because I see 35 and 35 is screaming to me that it's on the 5 times tables because of that ending in 5 thing. And so that's where that number is coming from for those lucky snots who least common denominators just pop into their head. I got great news for you. The more you list out times tables, the more you practice counting by, the more intuitive this will be for you as well. I do want you to the point where least common denominators just pop into your head. That's how my life is, and it's an easier place to be than always having to figure it out. Let's take a look at the next one. What is the least common denominator of 1/2 and 7/8? Now, I have a lot of students tell me it's 16. A lot of those students who did so well on the last problem will be like, 16, yay, 2 times 8. That's not actually true, y'all, so watch out. Sometimes that just popping into your head thing fools you. Think about the 2 times tables and the 8 times tables. Don't skip over the 1 fact. The 2 times table starts 2, 4, 6, 8. That number 8 is actually on the 2 times tables, and of course it's on the 8 times tables. So those two numbers run into each other before 16. The least common denominator, the first time they run into each other is at 8. And you might say, my math teacher taught me to just multiply the two bottoms together. And I know that math teachers do teach that method. There's never just one right way to do math. Okay, guys, that method is sometimes taught for adding and subtracting fractions. It's not my favorite method. I have my reasons, but for those teachers who teach it, it is probably their favorite method and they have their reasons as well. So we'll just agree to disagree, but you still do need to understand the skill of finding the least common denominator. Whether you use it later or not in adding or subtracting fractions, it will come up in its own merit and as its own kind of a problem. In both the first 5 problems of the GED where you don't have a calculator, this could show up. Just find the LCD. And then multiplying together won't necessarily help you. You need to know what an LCD is. Or it could show up in a word problem. And once again, you would need to understand the concept. So that's my plug for being able to actually find an LCD and not skip this. So then example 3 says, what is the least common denominator of 8 and 12? Again, a lot of students just multiply 8 and 12 together and tell me it's 96. Yeah, I don't think so, guys. Think about your 8 times tables. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Would this be easy if I had my times tables memorized? Yes. But is it necessary? No. 25, 26, 27, 28, 29, 30, 31, 32. Okay, so I started with my 8 times tables a little bit. Let me start with my 12s a little bit. 12. Now 12 plus 12, I could count on my fingers or I could just add, is clearly and easily 24. And take a look. Boom. Their LCD is a lot smaller than 96. Now, would 8 and 12 have 96 in common? Yes, it would be a common denominator, but it's not the least common denominator. And so 24 is the answer here. 24 is the least common denominator. You don't have to make it look like a fraction. You don't have to do anything else. You just have to write the number 24. That is the answer there. Now, if I were adding or subtracting fractions, I would use this to do something. But if the question is just what is the LCD, that's all I do. I just write it down. Okay. So next question. Example 4 says, what is the LCD of 9 32nds and 11 40ths? Now this is why I wanted to do this problem. Could I just list out 32 and list out 40 as times tables like I've been doing? Yes, I absolutely could, but it might take you a while. And I'm just gonna, just off the top of my head here, I'm just guessing, I don't know you, but I think you don't know your 32 times tables. Those are not memorized. Now you might be able to pull off your 40s, but your 32s would be a challenge. And so I'm going to use my other LCM method this time to find the least common multiple of the two denominators. Again, I'm just looking at the two denominators. I want to find the first time they run into each other on their times tables. And I'm going to use that prime factorization method where I build an LCM out of common factors. So first of all, let's figure out what 32 is made of. 32 is the same as 8 times 4. Of course, 4 is made of 2's. 8 is made of 4 times 2. Now 2's are prime, so I'll stop there, but 4 is composite. I'll keep going. And this is why I said you needed to know prime factorization for this video. I'll do the same thing with 40. 40 is the same as 5 times 8. Now 5 is prime, but 8 is composite. I'll keep breaking him up. 2 is prime, but 4 is composite. I'll keep breaking him up. And there are my prime factors. So I get down to my prime factors. Now remember, we're going to build an LCD out of all the factors that are there, not just the shared one. That's a different method. All the factors that I see, but I don't have to double up if it's shared. And let me show you what I mean. They share a 2. I only need 1 2. They both have that 2. Again, they share another 2. I'll put another 2 for that shared 2. Notice how I'm crossing 1 and 2 off of each. Then they share another 2. I'll put that 2. Now you have some extra factors. Now, the only difference between GCF method and LCD is whether or not you use the other factors. With LCD, I'm now going to use all the remaining factors. So there's no more shared ones. I'm going to grab the 2, and the 5. The 2, and the 5. And that right there will build my least common multiple or least common denominator here, since I'm talking fractions, but they're the exact same skill. Okay, so 2 times 2 times 2 is 8. Let's see, 2 times 2 is 4. times 5 is 20. And again, I'm doing the work in my head because I'm just too lazy. And 8 times 20 is 160. 160 is the LCD of 32 and 40. You would have gotten something much larger if you had just multiplied 32 and 40 together. Okay, almost done. Last example. And this is the one poor Shelby has put up now with like 30 minutes of videos just to get to the one problem she asked about. Okay, so here it is. What is the LCD of 5 42nds and 7 30ths? So again, a reminder, the LCD stands for least common denominator, but it's the first time the two denominators run into each other on their times tables. Again, could I list out the 42 times tables and list out the 30 times tables and find the smallest number they have in common? Of course I could, but it's not always the fastest way, and I'm lazy. So I will break them down to see what they're made of and build an LCD. So 42 is the same as 7 times 6. 7's prime, but 6 is not. 6 is made of 2 times 3. 30 is the same as 5 times 6. 5 is prime, but 6 is not. 6 is the same as 2 times 3. Now, you could see that they both have that 2 times 3. That's 6 in there. And so I will give the 2, remembering that I can take that off of both of them if it's shared. I'll give the 3. I'll take that off of both of them if it's shared. And then I will give myself every extra factor that I see in order to build the LCD. That's the difference between a GCF and an LCD. The LCD has the extra factors, which throws students for a loop because they're like, but it says least. Yeah, but it says least common. Multiples get bigger, okay? So 2 times 3 is 6. 7 times 5 is 35. And 6 times 35, did I just run out of cool? Let me see. 35 times 6, 30, 21. Okay. 210. So the LCD of 42 and 30 would be 210. Great. I hope that makes sense. I cannot think of a single more useful skill in math than divisibility. This is one small part of divisibility, but it's all about playing with these numbers, pulling them apart, building them together, and messing around with factors. And it is dead useful. Okay, guys, so a lot of students don't understand why I want to spend so much time here, but it's way more useful than just memorizing the steps of fractions, okay? Anyway, if you have any questions about this or any other GED topic, be sure to drop it in the comments, GED, math, whatever, and I'll do my best to answer them.